and we're going to look at chemical equations and percentage mass composition. So the learning intentions are to calculate percentage mass composition, to understand how to balance a chemical equation, and from these balanced chemical equations, calculate the mass of the reactants and the products and the volumes of gases that are present. So to begin, let's look at a definition of stoichiometry. So stoichiometry is the relationship between the amounts of reactants and products present in a chemical reaction. So the next calculation that we're going to look at is percentage composition by mass. And the percentage composition by mass can be readily calculated from the formula of the compound, the chemical formula. The subscripts in the formula of a compound tell us the number of moles of each element in 1 mole of the compound. So for example here, CO2, there is 1 mole of carbon for every 2 moles of oxygen. So 1 mole of carbon dioxide has 1 carbon and 2 oxygens. So the percentage composition by mass can be calculated using this formula here, where it's the mass of the element in 1 mole over the relative molecular mass of the compound. So let's take a look at an example. So, find the percentage mass of oxygen in ethanol. So the first thing you need to know is that ethanol is C2H5OH. Step 2 would be to find your molecular mass, and the reason you're finding that is because of the formula. And here it is. So the relative molecular mass of the compound, that's why we're finding MR. Then you find the mass of the element you're looking for in 1 mole. So we have that the mass of oxygen is 16. So then you just fill into your formula. The percentage of oxygen is 16, which is the mass of the element in 1 mole, divided by 46, which is the relative molecular mass of the compound, and you multiply that by 100, and you get 34.7%. You could then be asked to find the percentage mass of hydrogen in ethanol. So the mass of hydrogen, there is 6 hydrogens. So this is where I get the 6 from. It comes from 6 multiplied by 1, because there is 6 atoms of hydrogen, and they each have atomic mass of 1. So 5 and 1 is 6. So the mass of the element in 1 mole, there's 6 in every 46, because 46 is the relative molecular mass, multiplied by 100, so hydrogen accounts for 13%. Now, if you would then went and done carbon, for example, for carbon, you would see that the mass of carbon would be 12 by 2, because there's 2 carbons, so that would give you 24. So your percentage of carbon would be 24 over 46 multiplied by 100, and that would give you an answer of 52.2%. And if you add all of these percentages up, the 13, the 34.7 and the 52.2, they add up to 99.9, so it should add up to 100, so you would know your answer is correct. So what we're going to look at now is we're going to look at balancing equations. So a balanced chemical equation shows the amount in moles of reactants and products involved in a chemical equation, and there is no change in the number of atoms. So the left side of your equation should always equal the right side of your equation. So there's 3 steps to balancing the equation. Identify the reactants and products by name and write a word equation. Write down the correct formula for the reactants and the products, and then balance the number of atoms of each element by inspection by writing numbers in front of the formulae as necessary. Now this first step may not always be needed, as they may give you an equation already with formulae and just ask you to balance them from there. So let's start with wanting to write a balanced equation for the reaction of sodium and water. So the word equation is sodium plus water gives us sodium hydroxide and hydrogen gas, and we know that it's sodium hydroxide because it's a group 1 metal reacting with water. So our chemical formulas are Na for sodium, H2O for water, and NaOH for sodium hydroxide, and H2 for hydrogen gas. Now, it's important to remember that this equation may be given to you already, and you might just be asked to balance it. So you do it as follows. So if we look at our sodiums are okay at the minute because we've got one sodium and one sodium. But if we look at our hydrogens, we've got 2 hydrogens on the left, but we've got 1 plus 2 is 3 on the right hand side. So what we need to do is we need to add some hydrogens on the left, so 2H2O. Now that leaves me with 4 hydrogens on the left hand side, but I will still only have 3 hydrogens on the right hand side. So what I want to do is I want to get a 4th hydrogen, so the easiest thing is to add a 2 in front of your NaOH. Now at this point the hydrogens are balanced. We've got 4 hydrogens here and we've got 2 hydrogens and 2 hydrogens, which is 4. Our oxygens are balanced because we've got 2 oxygens and 2 oxygens. Reactant side, and at this point now your equation is balanced. So we've just looked at balancing equations, and we know that they tell us the amount of substances that react together and the amount of products that are formed. And this type of information is very useful, and it enables us to perform calculations to determine the amount of reactants needed to produce a certain amount of a product. So we're going to look at using the masses of reactants and products for calculations. So the steps to solve these problems: the first thing you'll always do is write down the balanced chemical equation and circle what you know and what you want to know. Then you're going to write down what we know on the left hand side and what we want to know on the right hand side. If this isn't already in moles, in step 3 you convert what we know into moles and what we want to know into moles. Then convert them to grams and complete calculations to find the number of grams of product needed for a given reaction, or vice versa. So let's explain this with an example. So for this example here, it tells us that a student is told to make 100 grams of magnesium oxide by burning magnesium in excess oxygen. So how much magnesium should the student burn? And then it says that magnesium reacts with oxygen according to this balanced equation. So the first thing that you want to do is you want to write out your balanced equation, and you want to circle what you know and what you want to know. So we know that there is 100 grams of the magnesium oxide, and we want to find out how much magnesium needs to be burned to produce this. So what we know is the magnesium oxide, and what we want to know is the magnesium. So we need to arrange this as we are supposed to according to the steps. So we put what we know on the left hand side, which is the magnesium oxide, and we put what we want to know on the right hand side. So we've done that now. In step 3 you do the moles. So you can see from the numbers in front of our molecules or compounds that there is 2 moles of magnesium oxide and 2 moles of magnesium. So the next step is to convert that into grams, which we do. To convert that into grams, you do the moles multiplied by the molecular mass. So the molecular mass of your MgO is 24 plus 16, which is 40. So that's where the 24 plus 16 comes from. And the MR of your magnesium is just 24. We're multiplying by 2 because it's 2 moles that we have. So that leaves us that we have 80 grams of magnesium oxide and we need 48 grams of magnesium to make that. However, we know from our question that we want to make 100 grams of magnesium oxide. So I would always go back to 1 gram and then go and find 100 grams of your magnesium oxide. So to get 1 gram, you divide both sides here by 80. And to get the 100 grams, you then multiply whatever answer you get by 100. So that means to produce 100 grams of magnesium oxide, we need 60 grams of magnesium. So we can also use our knowledge on balanced equations to calculate volumes of gases. And we've already learned in the mole that 1 mole of any gas occupies a volume of 22.4 litres at standard temperature and pressure and 24 litres at room temperature and pressure. So we can use this to calculate the volumes of gases used up or formed in chemical reactions. The key thing here is that instead of measuring the mass of a gas, where you usually measure the volume of a gas. So the steps are quite similar to what we've done already. You write down the balanced equation and circle what we know and what we want to know. And then you write what we know on the left, what we want to know on the right, the moles of what we know on the left and the moles of what we want to know on the right, convert to grams, and then complete the calculations to find volume of gas needed or volume of gas formed. So let's look at an example. It says carbon dioxide is formed when carbon is burned in oxygen in the air according to the equation below. What volume of carbon dioxide at STP is formed when 30 grams of carbon is burned in excess oxygen? So the first step is to write down your equation and circle what you know and what you want to know. So what we know is that we have 30 grams of carbon, and what we want to know is how much carbon dioxide is produced. So step 2, you write down what you know on the left hand side and what you want to know on the right hand side. So we know that we've carbon and we want to find out the volume of carbon dioxide produced. So how many moles of each do we have? We've 1 mole of each because the number that's in front of each of these molecules is 1. So we need to find out now how many grams there is in 1 mole of carbon, and 1 mole of carbon would simply be its atomic mass, so it will have 12 grams, and 1 mole of carbon dioxide is 22.4 litres. Now this is the important part here. You are writing what you want to know in terms of volume. Okay, and it's in terms of volume because the question says carbon dioxide at STP. So if that was 2 moles of carbon dioxide, it will be 44.8 litres, etc. But always work in the units that you want to in the question. We've got 30 grams, so we need to figure out what volume is 30 grams. So I always say it's easiest to find 1 gram, so that's dividing both sides by 12, and then you're going to multiply both sides by 30 to figure out how many litres correspond to 30 grams, and we see that 30 grams corresponds to 56 litres. So that's it for this video. Have a read of the learning intentions to make sure you understand